also have a channel on Discord. So if you want to discuss beyond our workshop, please use also the Discord channel. All FSE participants should have access to this Discord. All right, so now I'm very proud to introduce Peter Schrammel, our first tutorial speaker today. Peter is a lecturer at the University of Sussex in Brighton, UK, and is also a co-founder and CTO of Diffblue. At Diffblue, he and his team are working on the product Diffblue Cover, a tool for the automated generation of unit tests for Java code. So you see it's a perfect match for our workshop today. We are very happy to have you, Peter. In his tutorial today, he will present us how to use the Diffblue Cover tool, and which by the way also comes with a very neat IntelliJ plugin. So I think Peter will also show us here how to use this today. So Peter, thank you for your time and your effort. And now the stage is yours.
Good, thank you. I hope you can see my screen.
Yes, we can see your screen.
Excellent. Good. So, so I'm going to show you Diffblue Cover, and I'll give you a brief overview of what it is and how it works. And then I will show you 3 use cases of how you could use the tool for refactoring code when implementing new features or together with TDD. So please, if you have any questions, just interrupt me and I will try to answer them immediately. Good. So what is Diffblue Cover? So it's a tool that we have been developing over the last couple of years. And in the last year, we have particularly worked on a IntelliJ plugin. So you can get this plugin just if you have IntelliJ to go to Preferences, Plugins, Marketplace, and search for Diffblue Cover. And then you install the Community Edition. So this is freely available for use with open source code. So you can just download the tool and use it. So to give you a flavor of what the tool is doing, so I will work on a project that is a Spring Pet Clinic. So it's a simple Spring project that is also used by in the Spring framework tutorials as an example project. And so we have forked this into the our GitHub and Diffblue benchmarks, and you will see there the branches with different kinds of lessons that I will show you in this tutorial. So if you follow these commands here that you will see in the blue boxes up here, you can also do this at home or after the tutorial to see to follow the tutorial and do the lessons at home. Good. So the intro lesson here is so we have a simple Spring service here, cloud storage service, which communicates with Amazon S3 bucket. And there are 2 methods here: upload folder bucket and download folder bucket. And the first thing that we'll do is we will generate tests for this and see what the tool produces. So I hope you can see now my IntelliJ. So if I right click here and say write tests, then you will see that the tool starts. So the first thing it does, it makes sure that your project is compiled, because the analysis that we are doing works on the Java bytecode. And then it figures out there are 2 methods for which we want to generate tests. And then it runs the analysis on these methods to produce unit tests. So this takes a couple of seconds. So here we have a Spring project. So things that it has to do, it has to figure out what the Spring context is, load this context, and then it will try to find paths through the methods to write this. So here these methods are super simple. Essentially just call this S3 client and then produce this. Yeah, so this we'll see tests in a couple of seconds. So maybe a few words to this Spring Pet Clinic project. In the meanwhile, this is a a web server application for a vets practice. So you have different pages in here for managing pets and their owners and visits and so on. And so now we have got tests, and we can actually go there. And so we have the first test that has been produced. The second one has come as well. So what do we see here? So we have test upload file to bucket. So what we have here is, so we have to call this upload file to bucket. And of course, this communicates with an Amazon S3 bucket. And in a unit test, what we want to do is, of course, we want to mock the client that communicates with this S3 bucket. So what we have figured out, we're going to mock this client. So we have a mock bin here. And what this test is essentially doing here is it sets up the Mockito mock. So there are a couple of things that need to be set up. For example, for the object that is going to be put, we have to add an MD5. And then we have the actual call to the bucket. And here the assertion is super simple because there's not really that much to assert, because we're not really doing anything with the result that comes back in the simple method. If you look at download test file here, it's a similar structure. Again, the main work here is actually to set up the mock. So when we download the file from this bucket name / bucket key name, then what we get back is an S3 object. And what we have to do is to set up the content of the object. And here we just say, okay, it's a default string that we would use as a content of a file that we're downloading, but we have no idea what it is. So this is a quite simple tests that show some of the features of the tool. So it automatically mocks dependencies that need to be mocked. It can handle Spring, and also it chooses values here that kind of developer would use, even though there is absolutely no information in the project what would be reasonable values for this. Good. So you have the same steps here in the slides as well if you want to follow the tutorial at home. So to recap a bit what it's doing. So essentially it takes the Java source code, makes sure it's compiled, and then on the basis of the Java bytecode, it starts to create the unit tests. And what you get in the end is the source code of the JUnit tests. So here we had one test for each method, but of course, if the methods are more complicated, a couple of branches in them, then it will generate several tests. So it tries to trigger execution of paths through a method, and in particular, it uses inputs that are similar to what the developer would choose, and which makes the test look quite nice, and also mocks dependencies that should be mocked, and also figures out what useful assertions may be. And what is important to note, the assertions always reflect what the current behavior of the code is. So in particular, what doesn't do, it doesn't guess the intended behavior. So it will not figure out what you might have meant with what the code is doing. It will just show you what the current behavior is. It also doesn't replace all manual test writing. We'll see this in a second. And it creates unit tests. So don't expect it to create end-to-end tests like UI tests or what like. So any questions up to here? Because the next thing is we will look at different use cases. So you have in this box here what it supports. So it works on all the typical operating systems. The recent IntelliJ versions supports Java 8, 11, JUnit, Mockito, and Spring. So what should you use it for? It's for unit regression testing. So you create unit tests that reflect the current behavior of the code. And then later when you make changes, you can ensure that you haven't broken anything. It obviously speeds up unit test writing because it does quite a lot of heavy lifting in creating mocks and so on. And another application is you will find bugs by reviewing the tests. So we're now going to look into 3 use cases. So one is when I'm going to do refactoring, then when I'm implementing a feature, and how can I use it together with TDD, essentially. So first one is, yeah, so what is unit tests? To give you, so that we're on the same page with that. So if you look at the same test that we have created before, so essentially split into a couple of sections. The first one is the range sections that arranges input and mocks, which is highlighted in yellow here. The second one is the X section where we run the actual method on the test. And third, we assert what the effects of executing the method under tests actually are. And when we write tests, then we roughly follow this pattern to give you some orientation of how these tests are to be read. Good. First use case, refactoring. So this is on the branch A test refactoring, if you want to try this yourself. And we will look at the class pet type formatter, in particular at the method pass. So I switch to IntelliJ again. So first I have to check out the branch, of course. Just delete the test that we've created before. So pet type formatter. So here, so this pass method, what this does essentially, it takes some pet type and then looks it up into the database and then formats it in a certain way. Or it actually, it returns you give it some textual representation of a pet type and it returns the pet type. So we haven't got any tests for that, so let's create some tests. And what we would like to do with this method is, so it uses a for loop here to actually find the pet type. And what we would like to do is actually to refactor this into using streams, which is easily possible here with this logic. Yeah, so let's wait until we have created the test. Good. Here we are. So we've got a couple of tests here that now test the pet type formatter. So we can actually run them and should see that they hopefully pass. Yes, so these tests pass. So now what we can do is we will now refactor this code by to use streams. So instead of having this for loop, we have a stream, filter on it, then find the first match. And if we haven't found anything, then we throw this pass exception. So this is nice, makes it even a bit shorter. So now let's run this test again. And let's have a look whether we have broken something. Yes, and there is a problem here. So this test number 2 doesn't work anymore. And it says type not found dog. Okay, so let's see what this test is actually doing. So it's pass test 2. So it creates a pet type of type dog. So this is used to mock the pet repository. And then we look up a dog. So it should actually find this dog. So there's something strange here. So something doesn't work. So I guess we have to debug into this to see what is happening here. Good. So let's have a look what is going on here. So text is dog. So now we have to yeah, there can't happen much. There's probably somewhere here in this statement that something is wrong. So let's look into, even here it says type is dog, text is dog. So this must match somehow. Yeah? So something is really weird. This is interesting. So now we are in the integer class. So if a dog that is an integer, strange. How can this happen? Ah, now it's clear. It's the ID. And the ID is an integer. But what we actually have to compare is not the ID, it's the name. So this is what we want to do. Okay. So let's see whether this works now. Excellent, now all the tests pass. Okay, so while doing this refactoring, we actually have introduced a bug here, and luckily we had these tests now, and we were able to actually find the problem in our refactoring. So this, let me go to the slides. So this is the first use case here. So essentially we have created the tests, have done the refactoring. Inadvertently, the refactoring wasn't quite right. So we have introduced a regression here. And then by running the tests, we're actually able to figure out, okay, there was a regression. And by debugging it, we were able to fix it. So more abstractly, what has happened here is we had some existing source code. We created tests. So the unit tests. So those unit tests helped us getting a better test coverage and increasing the likelihood of catching regressions that might be introduced by the refactoring. We've done the refactoring, if they changed source code, ran the test again. If they had passed, everything would have been fine, but unfortunately failed. So we had to go back, find the bug that we introduced in the refactoring, fixed it, and the fix was successful. So we are ready to go and commit the source code and test it. So this was the first use case. Any questions so far? If not, then we move on to the next one. So now we are going to implement a new feature. And so this is on the branch a test new feature. So I'm going to check out this branch. And here we are going to add a new method, count dogs, to the owner controller here. This is a bug here. This should be owner control actually. So let me go to IntelliJ. Oops. Doesn't allow me for some reason. I think I have to stop sharing and reshare. Good. Some assume one. Good. I think it should work now. Good. You should see my IntelliJ window now. Good.
Yes,
so we
can
now,
see it.
yes, excellent. Good. So we're now looking at this owner control, and we said we are going to implement a new method here, count dogs. So what this is doing, we want to count the number of dogs that belong to a given owner. So we have implemented this simple feature here. Of course, we haven't got any tests for this. So let's right click here and write some tests. Still not sure what this didn't work before. It is. So what we're doing here is we essentially get the pets from the owner, and then we filter the dogs, and then we count them. A couple of seconds. And here we are, we have a test. We have even 4 or 5 tests here. Good. So what have we got? So first of all, we have a test with just empty owner, which doesn't have any pets. So we should have 0 here. This is correct. We have an owner that just has a last name, doesn't have any pets, so this looks correct. So what do we have here? So we have a pet here that is called Bella, is added to this owner, but we still get 0. So this looks strange. Why do we get 0 here? Let's have a look at the last test. So here with an owner, we have a pet called Bella, and we have another pet. So we have 2 pets, and we still get 0 here. So this is not really what we expect. So I would expect to have 1 here, because there is 1 pet, it's 1 dog, and here there are 1, 2 dogs. So we should get 0. We should get 2 here. So somewhere is a problem with our implementation. Yeah, so we have to, so let me try to run these tests. So I would expect these 2 tests now to fail. So this is, yes. So somewhere is a problem here with our implementation. So yeah, so I guess we have to debug into that to figure out what the problem is. So this is a breakpoint somewhere. This is correct here. Good, so let's step into this count dogs method. So what is going on here? So there is, again, there's not that much logic here. So the only problem can be in this filter line. So let me step into this filter line. So this is strange. So we're comparing dog with this Bella, but Bella is not the type of the pet. Bella is the name of the pet. So I think we've again fallen into a trap here, but we're comparing not the right thing. So this is the name of the pet, but what it actually should do is we have to compare the name of the type of the pet. So this now looks better, and let's have a look whether this actually fixes the problem that we had. So we run this test again. And now they work. So this is great. Yeah, so now we have implementation that is much more correct. So let's go back to the slides. So what has happened here? So we have created the tests, and then we have reviewed the tests, we've looked at the tests, and we found some behavior that is unintended. Yeah, so we have an owner that has a dog, but our implementation returns 0. So this is unintended behavior. And then what we did is we fixed the test to match the behavior that we intended, and then fixed the implementation. So more schematically here, so we started from our existing source code. So we implemented a new feature. Then we ran the tool to produce new tests. So these tests are candidate tests. So they're purely based on our implementation and show exactly what the behavior of our implementation is. So we review these tests. So if everything would have been fine, we could have moved on and say, okay, implementation is fine. But what happened during the review is that we spotted some unintended behavior. So we had to go back and say, okay, let's fix these tests so that they match the intended behavior, and then fix the bug in the implementation. So we ran the test again. If they failed, then we would have known that they our bug fix was still not correct. So we go around the circle. And when the test now pass, then we know that our implementation actually matches the behavior that we have specified in our unit tests. So this is what has happened here in this use case. And the important thing here is the tests show you what the behavior of the code is, and by reviewing them, you might be able to spot some unintended behavior in your implementation. Any questions to this use case?
I have one question, just to clarify, or maybe something new. Do you, or can you also replay now this information from fixing the unit test back to your tool, Diffblue cover? So that maybe next time you can generate a test which does not need to be fixed because it's actually already correct.
So the problem here is
I don't know how Diffblue cover works internally. So yeah.
Yeah. So what I said is the tests that we produce always show you what the current behavior of the code is. So what you suggested is that we actually essentially make an attempt to guessing what the intended behavior is, which is obviously a completely different thing because we don't know the specification, and there is no information what the specification should be in the code. So so only you as a reviewer can tell us what the specification is. So in this sense, we can't really feed this back,
Yeah, okay.
Because we wouldn't need to know what the specification is.
Okay, yeah. Thank you.
Great. Good. So last thing. So if you're using TDD, how would this work? And so we're looking again at the case where we're implementing a new feature. And here we're looking at a feature that is slightly more complicated. So we're looking at the branch A test TDD. And there we have a method process find form, again in owner controller. And so what should this process find form do? So we get an owner, and we should look up the owner in the database by the last name of the owner that we're given. And so if a single owner is found, then we'll redirect to the page that shows the owner information. And if several owners are found, then we are redirected to a page where we can select among these owners so that we can select one to be displayed. Good, so this is what this method should do. So what we have to do for this is we have to implement the tests. And here it actually starts to be really, really tedious because we have to implement all this boilerplate code for the test. And then we have to implement the individual test cases for this specification. So I'm now again going to show this in IntelliJ. So I have to check out the branch first. So we'll also remove the test that we had before. Good. So the owner controller. Yeah. So this was the. This is just the signature of the method that we're going to implement. There's nothing in there. Let's at least put the return null here so that the stuff compiles. So now what we have to do is we have to implement owner controller tests. So we need a new Java class, owner controller test. So now, yeah, as I said, we need some boilerplate here to set up the fields. Let's import this. So I'm going to speed this up because if I did this in real time, it would probably take me an hour just to write the two tests that we need here. So I'm going to paste the tests here. So this is the test for when a single owner is returned. So what we again have to do is here we have to mock what is returned by the owner repository. So this is a static method. Oops. This is also from the Twitter. So this is quite a lot of work to actually implement this test from scratch. And so we get this mocked owner back. We are looking for an owner with the last name Doe. And then, so we have one owner with the last name Doe, so we'll be redirected to the owner's page. So this is one of the cases that we had. The second case that we had was when we have several owners. And in that case, so we test here now that we have several owners, a Jane Doe and a John Doe. So now we are returning both owners, and Yeah, and we should be, since there are two owners with the last name Doe, we should be redirected to this owners list. Okay, so we have two tests now. Let's run them. So now, of course, we have no implementation. So we're expecting them to fail. And so what we're going to do now is to implement this process find form. Good. So what we have to do is just copy this. So we're looking up the owner by its last name in the owner's database. Get results back. If we have a single result, we redirect to the owner's page. Otherwise, we show selections to choose one of the owners to display. So great. Let's run this test now. Cool. So test pass now. Implementation seems correct with regard to these tests. So now we could call this job done, or we could see actually what Diffblue Ltd would produce for this method. So let's produce some tests. Yeah, so one thing maybe, how does this work here? So this find by last name is actually a repository, and this implements a database query. So what it does is it selects the owner from the owner table, does a join with pets, and it matches the last name via like last name. So we have a match with the last name here to return the respective owner. Good. So we got two tests now. Let's have a look what they do. So first test. So this is again a mocking repository. We return an empty result. And what happens then is we are forwarded to the owners list. So of course this doesn't make much sense. If we haven't found an owner, then we can't select any owner. So this is not quite what we want. It's also a case that we haven't had in our requirements. We might have got it if we thought a bit harder that this case might exist, but we haven't. So let's fix this test. So what should be the desired behavior be? So actually, if no owner is found, then probably what we should do is we should send the user back to the find owners page so that we can actually it can repeat the search string. So this is an additional case here that we have to implement. So let's fix up this test. So what we want is to send to find owners. There are no selections, so we can remove this. Good. So this should be a test that reflects that case. I would expect this test to fail now. Yes, it fails. Okay, so let's implement that. So the implementation that is missing here is that if we don't get the results back, then we send the user to the find owners page. If we now rerun this test, then this should work hopefully. Yes, okay, so this is fine. So we had another test here. So this test, okay, we have an owner. Okay, so database returns one owner. And we forward to the owner's page that was returned by a database. So the only thing here is interesting is there we actually have no search parameter that will search for a last name. So this is actually a problem. So this is not a mandatory parameter, and if we got null in here, of course we wouldn't get anything useful. So we have to actually do something about that case. And so we have to think about what actually the desired behavior should be in that case. And we could say, if no last name is given, then we just display all the owners and allow selection among these owners. So this is actually what this test is already doing. So returning all owners, and here we have only one match, so we forward directly to this match. So this is also one subcase of that. Good. So let's implement this. So this is another few lines here. We're essentially saying, okay, if the on search parameter is null, then we just set it to empty, and then this will cause that we return all the owners here. Good. So let's see whether this actually works. Excellent. So now we have got two more tests, and now the implementation actually, I'm pretty confident that this is more complete than what we had before. Good. So what is happening here? So let me go to the schematic here. So what is happening here? So we had existing codes. So we analyzed the requirements, implemented the unit tests. Then we implemented the feature, ran the tests, and of course, if one of the tests failed, then we would have a bug in the implementation. We didn't have this in that case. The implementation was correct. And usually we would say, okay, everything fine, let's commit. So now where the tool can help us is giving us additional confidence in our requirements and implementation. So actually the tests have passed. Now we run the tool, create new tests, so additional tests. We review these tests, and if we find some unintended behavior in these tests, then this means that we have missed something. So we have to go back to the drawing board, amend the requirements, fix the unit tests so that they match the intended behavior, and then we can fix the implementation, run the test again. We might need some more circles here to actually fix up the implementation. But eventually we'll have tests that all have intended behavior and an implementation that passes this test. So the value that we get from these tests here is that it will demonstrate some gaps in the requirements. So we have some chance if our analysis here was not quite complete, or if something occurred, some additional case popped up during implementation, that we will spot this, and also the writing of the test is then much faster. Good. So these were the 3 use cases that I wanted to show here. Any questions to this one? Then just a few remarks to close. So we've got this community edition plugin that you can download and you can use it for open source. There is also a paid plugin that you can use if you do commercial software development. There is also a CLI tool that you can integrate into CI. You can also try this in a sandbox environment if you go to this link. So to summarize, so Diffblue Cover is a tool that creates unit tests for Java. It doesn't replace software developers. But it complements and speeds up the manual test writing. So I think you have seen this, that this is much faster than having to type the test by hand. So the graded tests tell you what the current behavior is. And so this means in the different use cases, this has different consequences. So if you do what I showed you in the first use case, refactoring, then we create the tests before, we make the change, and then we just run the test, and they might demonstrate us unintended changes in the refactoring that we did. So we spot bugs in the refactoring that way. If we implement a new feature and we create the tests based on our feature, then the tests can only show us a bug by reviewing them and spotting some unintended changes. Then we'll have a demonstration of a bug implementation because the tests show us what the current behavior of the implementation. And in TDD similarly, so we have written some tests based on the requirements in the beginning, but then when we run the tool, it might demonstrate some gaps in the requirements that we have because we have missed some case, or the implementation, during the implementation, some additional cases were implemented that we were not aware of while doing the requirements analysis. So it gives us a kind of last chance to find some gaps in the requirements that we might have missed. So we would like to have your feedback on this, and so we'll drop this link also into the Zoom chat. So there are 5 questions, and we would be very grateful if you could fill them in. You can also fill them in after you have tried the tool yourself. And if you have any problems with the tools, you want to give feedback, it doesn't work on your machine, or you don't get tests on a certain project, or you want to have some additional feature, then you can go to the forum.diffblue.com, and you can ask your questions there, and we'll provide you with support. Good. That's all from my side. Are there any additional questions?
Thanks, Peter. Actually, I have one question about the coverage in the generated test. So did you take into account the coverage when you create the tests? So does the test reach a certain percentage of coverage in the user code?
Yes. So the test generation that we do is to a certain degree guided by coverage. So we're looking at the different branches and trying to cover the different branches. Of course, we can only cover different branches if we find suitable inputs that trigger these branches. So you might not always get full coverage, obviously. Yeah? Depends on how difficult it is to actually set up the object on a test, set up the arguments that are passed in, and so on. So depending on how complex this is, we might get more or less coverage.
Thank you very much. Are there any other questions?
I have a question. I was just wondering how, if you've tried to run this tool in Android Studio, because there's a big problem in open source Android apps that they're just not tested at all, really.
Yeah, we don't support Android Studio at the moment. You would have to use IntelliJ, unfortunately.
Okay.
Also, we haven't really tried it. We haven't really tried on Android applications at all. It would be
Okay.
could be a nice nice project to actually try the tool on it and figure out how we could improve it to make it work also for Android.
Thank you.
So I guess there will be some additional features required to support some special kinds of mocking the Android system and so on.
Yep. Thank you.
Yes, then the Android system now have the other problem with the Kotlin language, so it will require a parsing of another programming language. So the Android world is more complicated than that.
This is in principle is so actually generating tests is not the problem because it's bytecode based, and we have already produced tests for Kotlin code. So this I would expect to work. The only problem that you might have is that the tests that we generate are in Java; they are not in Kotlin. So we're not generating Kotlin source code yet.
Any other question?
I would have one more. I would be interested in if you can you tell us some more details about the underlying engine? Like I was reading on your homepage, you also do it like AI driven. Can you tell us a little bit more about that?
I cannot tell you too much about it. So the main, I think the distinguishing feature that we have is that we are trying hard to really produce inputs that look similar to what a developer would choose. So you will never find any kind of random strings or random numbers in there. It is always based on something that a developer would have in mind. And if we can't find anything useful, then we will of course fall back to some default strings like foo or something like that. But in general, we are trying hard to find something that appeals to also to the developer's eyes and makes the tests more readable.
Okay.
Okay, so thanks, Peter, for your tutorial. Thank you very much. And so if there are no other questions, we can have a brief coffee break. And we can start again at 1:15 p.m., so in about 15 minutes, with Michel Nas and